Hi, welcome back. This is the review for summative number 8 in the spring of 2019 for Algebra 2. We do have a couple of repeated sections on here, and the first one that you're going to see again is an oldie but a goodie, and it's solving logarithmic equations. So you really have to kind of get back to the idea of how in math do we undo a logarithm, and the answer to that question is we do this by exponentiating. So you figure out the base of your logarithm, and then you basically shove that base underneath both sides of your equation, and that's the mathematical action that undoes a logarithm feature. But you can't do any of that work until you've isolated the logarithm. So our first task is to isolate this logarithm right here. So we're going to subtract 3 before we get going. So you have logarithm, and this is a base 10 logarithm, it's a common logarithm, of x minus 1 equals 3. So now here comes the exponentiation step. So you take the base of 10, which is the same as the logarithm base, and you shove it underneath the problem on both sides of the problem, like this, okay? So 10 raised to the log base 10 power, these cancel each other out. That's why we did the exponentiation step. So then the x minus 1 just kind of drops down. There's no longer a base holding it up. And then over here, this is 10 to the third power, which you could type on your calculator with a caret, but it is 1,000. And then final step here, you're going to add 1 to both sides, so the answer is 1001. So trick on this section is to understand, the process, isolating the logarithm, and then to know to exponentiate, and also knowing what the base is for any particular type of logarithm. So like here on number 2a, we need to isolate the logarithm before we do any exponentiation work, so I'm going to need you to isolate this part right here. This is going to take 2 steps, so we're going to add the 5. So we have 6 times the natural log of x plus 9 equals 12. And then again, we're not isolated yet, so you need to divide both sides by 6. Okay, now that we have the logarithm isolated, which happens to be a natural log this time, you have to remember what the natural log base is. So on your calculator, you'll notice the button for natural log has an e to the x power above it. That's because a natural logarithm is the same thing as a logarithm of base e. So when I go to choose my exponentiation number to shove underneath the problem, I'm going to choose the number e. So e raised to this power and e raised to this power. Now unfortunately I don't know this off the top of my head, but I do know that e raised to the natural logarithm function is going to cancel. I didn't give myself enough room here. Alright, so I'm going to work over here now. So the x plus 9 drops down, and then e to the second power is something I'm going to need to type on my calculator. So I actually don't know what that is. I got to bring that up. But first I got to find my calculator. There we go. So I like to use the second natural log key because that already brings up an exponent position. So e to the second power is, I'll write down 7.39. Where'd you go? There you are. 7.39, right? I don't know where it said to round. Did it say? Not really. So give me at least 2 decimal places whenever you have to round something. So final step here, we're going to subtract 9 from both sides, and I never do a decimal subtraction in my head. So I get x equals, I don't know, because literally I will not do this in my head. I refuse. Minus 9. Oops. Get my ink off of here. Gosh. Okay, minus 9. So negative 1.61. So you're going to see a few questions on solving logarithmic equations. So you have to know, like, who's your base, how do you exponentiate, all that good stuff that we just went through. How do you isolate before you exponentiate? And then this is something new we're going to try this time. We're going to have a bonus question because this is not the first time we've tested this section. So if you feel like a little bored or you want to be challenged, there's going to be a bonus question at the end of the section. It'll be very obvious. It'll say bonus. It'll have a box around it. It's going to be more challenging than the typical question that I'm asking everybody. So if you can execute that bonus question properly, you will get extra credit essentially on your score. So I'm not really sure what it's going to look like for you in particular because it depends on how you did, but if you got everything right and you got the bonus question right, you'll get a score that's higher than a 5, so you'll get extra credit. If you made like a small mistake somewhere in your work but you got the bonus question right, basically I'll forgive your small mistake and I'll just give you your 5 that you truly deserve, okay? So try the bonus question if you feel up for it, but it does have a little note here. You should look at the end of 7.5 solving log equations. solving log equations using properties. There's some questions at the end of that section, and you can revisit my video on 7.5 Part B, Part 2 I think I called it, where the very last few questions, those are the style of question you're going to see. They are harder, and that's why they're extra credit. Alright, so this section is new. Everyone's going to get their first time score here, so let's see how it goes. We're going to be simplifying, multiplying, and dividing rational expressions. So in our little card it does say, you know, when you're simplifying an expression, look for factoring and factor everything. So let's do that. We're going to factor x squared minus 64, that's the difference of two squares, and it factors into x plus 8 times x minus 8. And then our denominator is a standard trinomial, so all the factoring you see on this test is going to be very basic as far as like the style. You're only going to see the take out the common factor, the difference of two squares, and then the trinomials are the type of factoring you're going to run into. So I know it's x and x. I need them to multiply to negative 16 to add up to negative 6. So what if we tried a negative 8 and a positive 2? And I need to double check all my factoring, and everything's good. So now I go through, once I'm triple checking my factoring maybe, and I'm going to cross off any exact expressions that will cancel. And that leaves me with my simplified answer of x plus 8 over x plus 2. This is the final answer. There is no further canceling that you can do. And if you're concerned that you might be the kid who tries to cancel things improperly, then I need you to put parentheses around your expressions like this. And I think that'll stop you from doing some illegal canceling. Alright, these two questions, notice there's no factoring in these questions, so that's kind of nice. But there's a whole bunch of monomial mess going on, so what I'm going to need you to do is smush them all together. That's the word we use, not the official math word, but that's what I use. So I'm going to smush all the numerators together into one massive numerator, and I'm going to smush all of the denominators together into one massive denominator. So I probably should have grabbed a calculator. I think I have one on my phone here. I'm going to multiply all those coefficients together up top. And it's like 7:30 in the morning or something, so I guess it's almost 8. Either way, I can't do mental math. Okay, 21 times 4 times 5 is 420. And then all the x's, I have x to the 5th and x to the 9th, so we'd be adding those up, and that's x to the 14th, using my exponent property, and then there's still a y squared as well. So there's my smushed numerator. Let's talk about the smushed denominator. 25 times 49. I'm hitting the wrong thing. Whoopsies. Oh my gosh, can't type either. Alright, so that's, oh boy, 1225. And then I like to put them in the same order that I did the numerator, so x to the 5th would come next, and then y to the 12th after that. And now we really have to think way back when we used to simplify these. We would look at our coefficients, and we would reduce this fraction. Since we have a calculator, I'm just going to math enter that. So, yep. And even your math teacher does that on the calculator, because why would I want to not? Alright, so that coefficient becomes a 12 over 35. And then when I look at the x's, you could do this the long way, or you could just visualize it, or you can use the exponent rule, which says to subtract. So, subtracting my exponents, that would become an x to the 9th power. And then similarly here with the y's, we're going to subtract those as well. However, that is y to the negative 10th power, so I'm going to go ahead and move that to the denominator. Notice how there's more y's in the denominator of the fraction, so it's going to be heavy on the y's in the denominator. For when we have exponents that aren't fractions and they're really easy to visualize, a lot of you guys take a visual approach to that, and I think that really works out much better than like being strict and following your exponent properties exactly. Alright, number 5a. We are multiplying two fractions together. I noticed someone's already factored this, so that's awesome. So a little happy dance here. I'm going to write a note to my readers who are looking at the slide. So it's already factored, yay! So now I just have to treat this like a big gigantic fraction and do some cross-canceling. Alright, so the part that you need to be a little concerned about are the monomial parts, and we'll get to that in a second. Let's do the easy parts though. I see an x minus 1 that'll knock out, but only one of them will knock out, so be careful because there's an extra one. An x plus 3 will knock out, and then there will be some simplification here with the x to the 6 over x to the 8th. If you want to cross-cancel it right now, you can. If you're worried about it, then hold off. This is an x to the 6th times an x minus 1 over x to the 8th times an x plus 7. So we are not done because of these monomial features here, right? If you have 6 of them over 8 of them, that means when you subtract them, you'll have x to the second left here in the denominator. So your x minus 1 is still up in the numerator, but now you're going to have x to the second in your denominator over x plus 7. And again, I always encourage you guys to use parentheses around your binomial factors and your trinomial factors, because then you won't do anything weird with the cancellation that shouldn't happen. Alright, so there's some more canceling here. I'm going to write a little note to my slide readers. I know a lot of you just look at the slides. I don't blame you. Alrighty. Now we're dividing fractions. Again, someone already came through and factored, so that's nice. So it's already factored. So what you need to do is you need to flip and cancel. Sometimes I just write some keywords to kids when they're stuck on a question, and that would be something that might help somebody figure out what to do next. So as far as flipping goes, we're referring to the second fraction. The fraction that follows the division sign is the one that needs to be taken as the reciprocal. So you have 32x to the 9th over x, and now it's times x minus 5 over 8. Now, unfortunately, I don't really have a lot of like straight cancellation, and maybe you want to do some cross cancellation right now. That's great. If you're not sure, then just kind of smush this all together. So you have 32x to the 9th times x minus 5 over 8x. So clearly the x minus 5 is there for good. But this coefficient, you can math enter that or just divide it, can reduce, and also these monomial pieces can reduce as well. So 32 over 8 is a 4, and then x to the 9th over x to the 1st would be like x to the 8th, and then you already had an x minus 5, and since there's nothing in the denominator, you can say over a 1, or you can just say here's my answer. That works too. Okay, so I know some of you got to that same answer a little differently, and that's okay. You just have to decide how you're going to practice these questions. Alright, for 7a, we're back to multiplying fractions. Unfortunately, no one factored anything. So your first step is to factor, and then we're going to cancel. I do so enjoy the canceling. I think it's fun. Alright, unfortunately, you got a lot of factoring in this question. We're going to have to factor like everything. So every single thing that I'm boxing in here is going to have its own factoring questions. This is going to be a hoot. The good news is we're all very good at factoring. So as long as we're careful and we double check, we should be good to go. So x squared plus 9x, that's the kind of factoring where you take out a common term. It's always a good, if you're stuck on a question, always remember the flowchart. You'll always look for the common factor first. Alright, 10 does not, the red box does not have a common factor, but it's a regular trinomial factoring question. So multiplies to 9 and adds up to negative 10 would be negative 9 and negative 1. Alright, that green box, again, regular trinomial factoring, multiplies to 36, adds up to negative 13. How about a negative 9 and a negative 4? And then down here you have the difference of two squares. This is the one where you can square root each term. So it factors into x plus 9 times x minus 9. And now we get to do that fun part of canceling everything. So I'm going to use a highlighter since I'm out of colors here. Highlight away. Yeah, let's go with really bold yellow one, I guess. Okay, x plus 9s are gone. X minus 9, but only one of the x minus 9s can cancel with another one. And that's kind of it. So up in my numerator, you still have an x, and you still have an x minus 4. Leave it factored. And then down in the denominator, you still have an x minus 9 and an x minus 1. And that's your answer. Please don't take the time to distribute things, and that's just not worth it. Leave everything in factored form. Alright, here we're trying to divide, so similar idea, we are going to factor everything, except because it's dividing, we're going to need to flip and then cancel. My favorite part. So I'm going to kind of do this at, kind of in the same step. So I'm going to box everything in that I need to factor. I'm going to try to match up my colors, so that way when I write them down on the next line, I know who's who. I'm also going to remember, hopefully, to flip this fraction around as I rewrite it. So that blue box factors into, let's see, -4 and +2 would work. Of course, I would triple check that if this was my test. X to the 5th is a monomial, so it doesn't do anything. This is going to change to a multiplication problem because we're going to flip this around. This green box, you could factor out an x squared from everything, and that would leave you with an x minus 8, and that's all the factoring you can do there. And then this red one, that factors into, oh boy, let's see, x minus 8 times x minus 4. Okay, so there should be some cancellation here. If you don't see it right away on all the pieces, it's okay, you'll hit them eventually. I'm going to use my highlighter again. So x minus 8, one of those can cancel with one of those, minus 4 can cancel. And then there is going to be some cancellation on the x squared and the x to the 5th, but if you're not ready to show that cancellation, then just wait. So this numerator is an x squared times an x plus 2, and then this denominator is an x to the 5th. So this is where I'm going to notice, oh, I didn't catch my monomial reduction here. This is really x to the 3rd, but it's going to be in the denominator. So be careful on this one. The x plus 2 stays in the numerator, but then that x to the 3rd is now in your denominator because of, heavier on the bottom if you want to think of it that way. So there's our final answer. All right, and we're not doing any weird cancellation that doesn't belong, so good job us. All right, another new section is the adding and subtracting rational expressions. So the big idea here is that you need common denominators, just like in 4th and 5th grade. So you want to come up with the least common denominator ideally, and if it's your birthday, then you get something like number 9. It already has a common denominator, so yay, has a common denominator, check. So your answer is going to keep that common denominator of 5x minus 1. And then your job is just to kind of simplify the numerator. So you can write this as one giant fraction, 6x plus 3x plus 9. But then, of course, you want to simplify because no one likes that answer. So this is, let's see, 9x plus 9 over 5x minus 1. And that's a great answer. But some of you savvy test takers are looking at that going, oh, wait, Abruzzo, you can factor 9x plus 9. So if you factored a 9 out, you would get 9 times x plus 1. Over 5x minus 1, and because nothing canceled, oops, minus 1, because nothing cancels, frankly, your teacher would be happy with either one of those answers. So if you thought to factor everything at the end just to be careful about canceling, that would make me really happy. But if you happen to miss it on the test, I'm not going to, mark you wrong, because technically both of these are correct. So then maybe you'll get something like number 10, and you look at the question and you go, okay, this does not have a common denominator. So the first thing I'm going to do is I'm going to off to the side write down what my common denominator is going to be. Well, I notice we need an x and we need an x minus 7. So that's going to be your common denominator. So now my job is to build up the common denominator. So this first fraction is missing the x minus 7. Technically, you're multiplying it to both the numerator and the denominator. The second fraction is missing the x. Now what I like about these questions is once you come up with that common denominator, you don't have to do any more work. This is where the work shows up in the numerator. So you've got 5 times x minus 7, which I'm going to try to write with the same colors so we can match it up to our slides. And then there's a plus sign in the problem. And then there's 4 times x. I don't really need parentheses there, do I? Okay, I've just got to clean this up a bit. This numerator becomes 5x minus 35 plus 4x. Common denominator, always leave it in factored form because I like to see the pieces. And then adding the 5x and the 4x together, you get 9x minus 35 over x times x minus 7. Most common mistake on this section. Kids just kind of leave off the common denominator. Like they understand that they're supposed to get one, but for some reason in their math, their denominator has disappeared. So you need to really be careful about that. Oh, this question, it looks like it's your birthday again, right? Oh, has common denominator, cool. Yay! So then you look and you're like, okay, well it has the common denominator of x minus 5. So Bruzo, this must have been a very easy question. How nice of you to give me 2 easy questions on my test. Well, I think you guys know me well enough to know I'm not going to be this nice. This is a case where if you don't think about factoring at the end of your question, you're going to be in trouble. This numerator, this guy right here, Totally factors. Let's start with the common factor. There is a 9x that you could take out of that. And if you take out a 9x, you still have x minus 5. Uh-oh, so glad we thought to factor, because look what's going to happen. Your numerator and your denominator both have a term of x minus 5, so these are going to cancel. And then you end up with an answer of just plain 9x. You could say 9x over 1, but it's 9x is a good answer as well. So watch out for a question like that. I am going to sneak that concept on there because that's an important one for us in Algebra 2. Alright, and then the big kahuna here. They do not have common denominators, so that's a bummer. We're going to need to get common denominators, and right now it looks like our common denominators are going to be a lot of work. But wait, look at this denominator. I think if we saw him in terms of his pieces, in other words, if we factored it, we would have good luck in our future. This factors into 3x plus 1 times 3x minus 1. So the reason I want to factor that denominator is because I don't want to give myself too much of a denominator. When I look at my denominators now, I notice that the things they have in common between the both of them is they both have a 3x minus 1, and then one of the denominators also says I need a 3x plus 1. So to complete this denominator set, you need to make sure everybody's denominator matches that one. Well, I have excellent news for you. This fraction is good to go. This fraction is not. It's missing the 3x plus 1. So when I go to write down what's going on in this numerator, which I know looks really messy right now, I'm going to write it down here. I'm going to try to match up my colors. So you have 5 times 3x plus 1, the quantities. We're going to distribute that in a minute. And then notice what's going on here. They have a subtraction sign, and even though we didn't multiply this fraction by anything, we do have to remember to distribute the subtraction through the 7x minus 4. So we'll get to that right here on this step. So let's distribute the 5, clean up our numerator. On your card, your yellow card, it says to simplify the numerator. So that becomes, let's see, 15x plus 5, and then a minus 7x, and then a plus 4. Leave that denominator factored. Once you set up that common denominator, I never want you to do any simplifying to it unless something cancels at the end of the problem. Alright, almost home free here. I should be drawing some arrows here. What do we have? Let's see, that's 8x plus 9, which doesn't factor, so yay, over 3x minus 1 times 3x plus 1. Any order on those factors, order doesn't matter for multiplication. If you want to put parentheses around this, you can. The good news is we're done. So that would be one of the challenging questions on that section. That's really going to show me who understands how to get common denominators. And then we're going to bring back this calculating probabilities section. So remember, we have an AND problem, we have an OR problem, and then we're going to be having a conditional problem. So they're all different in their approach, but something that these two have in common, because they're AND and OR, they're going to be out of the total 119. So without actually doing a lot of work, I can at least write down 119. So for AND, you're going to go pluck one number out of the chart to find all the people who play soccer and are female. So soccer female, that would be this lady's right here, 14. Now the next question looks similar, but one tiny difference, but it's a huge difference. It says soccer or female. So what I like you guys to do is to tell me all the soccer people plus all the females, and then subtract the female soccer players because you counted them twice. So all of the soccer players are these 24, plus all of the females would be these 59, and then we're going to subtract these 14 female soccer players because you counted them twice. So, oh boy, that should be 69 over 119, which might reduce, I don't know. And then one last one here, the given female. We're going to be looking at just the data from, whoops, I was supposed to highlight that. Just the data from the female players. So your denominator this time is out of the total females, so 59. And out of those 59 females, how many of them play soccer? That would be 14. So notice each one of those questions looked almost identical with key differences and obviously very different answers. And then this last question you're going to see again, you need to compare the three percentages to figure out who has the highest percentage. So you're going to start with like, whoops, Papa John's is 45 out of 100, which is 0.45. And then there's another survey that talks about Pizza Hut, which is 30 out of 121, which I haven't calculated yet. And then the third survey is Domino's, which is 43 out of 63. So this one's small. This is like 0.2 something. I'm not sure what. This is 0.6 something. I don't have a calculator open. So we're looking for the two largest percentages, and that would be Papa John's and Domino's. I spelled Domino's. There we go. So look for the two largest percentages and go with that. Now there's a note here. There's going to be a bonus question here so you can get some extra credit. Make sure that you are very good at reading SAT style probability questions, which means you're a very careful reader. All right, good luck.